くお願いします。
Hi, minasan konnichiwa. My name is Alex Kane. I am from Brooklyn, New York City. I work for a company called Tunecore. And what we do is we distribute media files from artists and musicians to online digital stores such as iTunes and Amazon MP3 and others. The name of the company is Tunecore. It's www.tunecore.com. And what I'll do is I'll tell you about a little bit what we do, and then I'll spend some time talking about how we do it technically. So like I said, our customer would be an artist, a musician who has some music they want to sell. And in the past, what they would have to do is go to a record label and go get a record deal and have the distributor sell their physical CD at the store, like in Tower Records. But now with iTunes Music Store, we don't have to do that, right? The artist can just upload their music directly to the online store and get the profits without going through a record label. So the user's experience at our website will be, they will come to our website, they will upload their album assets, which would be their songs and their album artwork. We take a variety of formats. We take MP3, WAV, FLAC, TIFF, JPEG. We like to have the higher bitrate files if possible, because that means the quality will be better for the consumer. So they'll upload their files, and we will then process them, create a package that is sent to iTunes and Amazon and Rhapsody and the different stores. Each store has their own specification on how they like to receive the data. I'll talk more about that later. 45 days after your album gets onto iTunes, you will receive an accounting statement. So the customer will come back to our website after 45 days, and they will be able to see every sale that their album had, which is kind of cool because they can then transfer the money from their Tunecore account into their bank account electronically using PayPal. Okay, so just to go over again how this works, the artist will send an MP3 to Tunecore. Tunecore acts as the middleman. We send the MP3 over to the iTunes Music Store. Then consumers will start buying it. They listen to it, they like it, they download it. Each track costs 99 cents. They send the money back to Tunecore. Tunecore then sends the money back to the artist. One of the cool things about Tunecore that's really unique about our business model is that we let the customer keep 100% of all the profits they get from the sales of their music. So it's really empowering for the artist. They no longer need a record label. And in fact, they are their own record label. Okay, a couple things about Tunecore. We launched in January 2006. Jeff Price is the CEO. He has 17 years of experience in the music industry, and Gary Burke is the technology lead. The two of those guys primarily put the site together and launched in January 2006. End of 2006, Tunecore was getting some press and some attention because of such a unique business model. Guitar Center came in and bought a significant amount of the company. and therefore partnered with us. Guitar Center is a huge, huge billion-dollar company, retail chain in the United States, and they sell everything from guitars to keyboards to mixing consoles to Pro Tools software, anything that a musician would need. We have 75,000 accounts in our system, and we do 100 new albums through our service every day, just to give you an idea of how much traffic we get. One thing to note about Tunecore is we don't depend on a lot of traffic to earn money. We're not a social network. We're actually selling a service. So when I talk about scaling Tunecore, I'm actually talking about scaling the back end of the system where we connect to the stores and do a lot of transcoding and things like that. Really cool. Tunecore customers have earned $8.5 million using our service by selling their songs on the online digital stores, which is great if you're a musician because it's a lot of money. Okay, so who are the customers? Ziggy Marley is a customer. He published an album with Tunecore, and he was able to get a ton of recognition and many, many sales from that album, and he won a Grammy by the album that he published on Tunecore. Frank Black of the Pixies is a Tunecore user, as well as Jay-Z, also from Brooklyn. And we have some famous customers, but most of our customers are independent musicians. They're not necessarily big famous people. They're mostly artists that promote their music online on YouTube, get sales, and they make a decent amount of money. So that's what Tunecore does. Now I'm going to talk a little about how we do it. This is the part that I like. So there's two parts to Tunecore. One is the front-end website. That's the part where the customer will come and upload their data and get their accounting. It's pretty straightforward customer accounting system, nothing to break through there. It's a Ruby on Rails app, runs on MySQL. We have one monolithic database, just one big database with everything in it. For performance, we do some fragment caching, and we do our uploads via MERB. And this is the one thing on the front end that was difficult to scale. Because if you take a 50 megabyte WAV file and try to upload it through a Mongo process, you're going to have problems, because that Mongo process is going to block all the other users that are trying to come to your website. So what we did was we used MERB in a separate application, separate server, to handle the uploads, and then that reports back to the main application and kind of gets everything in sync. And I think a lot of sites are doing this. It's a pretty common approach. Backend is where it really gets a little hairy. This is where all the heavy lifting is done. We have a distribution engine that runs on virtualized servers inside the Amazon AWS web cloud. I don't know if you guys are too familiar with that. Are you guys really, raise your hands if you use the Amazon AWS. Cool, cool, cool. Okay. So yeah, it's really, really good for startups because they don't have to spend a lot of money to get a lot of resources. So what we use it for transcoding audio, writing a metadata file, and then we turn around and we send that package to the store. That store could be iTunes, Amazon, Rhapsody, Napster. There's a ton of different stores. We support about 8 unique online stores. And they each require a different format, and some of them require WAV files, some like FLACs, some require multiple different formats. Some take MP3s or even Windows Media. So it gets kind of tricky. Each implementation of a different store is different. And when we add a new store to the system, it takes time to add that module into our distribution engine. Okay, so how is it written? It's mostly Ruby. I'd say about 90% of it is Ruby. We do use open source transcoding tools to convert between the different formats that our users give us and then what we have to send to the store. And for that, we just shell out to the operating system, which is Linux, and just handle it like that. It needs to be very modular because, like I said, each store is different, and we need to support each store's different package format. The stores often give us their schema in XML, and we haven't found a good way in Ruby to validate an XML schema against a document. So what we do is we use Java for that to validate our metadata before we send it to the store. Okay, so how do we connect the front end and the back end systems? We do that using message queues. Our message queues also exist inside the Amazon AWS cloud. It's pretty cool because what will happen is when you go to the website and you upload an album, when you pay for it, we take a look at your album and we create a YAML message out of it. That YAML message gets placed on the queue and waits to get processed by our distribution engine. And we have many, many distribution engines running at the same time, picking messages off the queue, processing them, and sending them to iTunes. So we can have different queues with different priority levels. We have a VIP queue that is for really important customers that is a pretty low traffic queue, so the messages get through there very quickly. Right, so it's formatted in YAML. Ruby's great for that. Take an object, dump it to YAML, stick it on the queue. The worker picks it up. It's YAML, converts it right back to an object, and it can work with it. And like I said, the queue is in Amazon, so it's cheap, and it works really well. It's pretty good. So the key to scaling our backend system has been virtualization, right? We want to run many engines, distribution engines, at the same time, right? And they're all pulling off this message queue. And what they do is they're going to grab a YAML message, which is an album, really. They go to Amazon S3 for the assets. They will take the assets, turn them into an appropriate bundle, turn around and ship them off to the store. The key to the virtualization is we can spawn many instances in a short amount of time, and we only pay for the cycles that we use. I think we pay by the hour. It's a very low rate. So if all of a sudden we have a lot of albums coming into the system that need to be sent to the stores, we can spawn many servers very quickly, and then process those albums, send them to the store, and then shut the servers down. So it's economical, and it's really efficient. For storage, as you can imagine, we have a ton of files that we have to store. And they're really big files, like WAV files, and really big artwork files, because every album has artwork on the front cover. So we keep all our storage in the Amazon AWS cloud as well. We have over 2 terabytes in there. It's all accessible via HTTP, meaning if we need to serve it back to the client for any reason, they can serve it directly from the Amazon S3 service. It doesn't have to go through our servers, which is really cool. Data transfer within the Amazon Web Cloud is free. So if we're going to transfer a file from the S3 bucket to the virtual server where we need to process it, that data transfer is free once we upload it into the cloud. Okay, summary. Rails on the front end, Merb on the front end for uploading files, Ruby on the back end for transcoding and creating packages for the stores. Virtualization is very, very big on the back end. We don't use it on the front end at all because, as other people have commented, database right now is not a good place to live in a virtualized server. Doesn't work very well. S3 for online storage is huge. Rather than buy an expensive storage array or SAN unit and put it in our data center, we use the Amazon cloud, which is very, very cheap. And the message queues are essential for communicating between your front end and your back end systems. I would recommend going for an Amazon managed queue. That's a service they provide for a small fee, and they manage the queue for you, and it's something that kind of you don't have to worry about. Just to finish up, we have an API that just got released. That's the URL for it, and it lets people build services on top of our distribution engine, and you can do your own business using our web service. So you can take a look at that if you're interested. The API has a Ruby SDK as a reference implementation, which is open source. It's on the Google code. My email address, if you guys have any questions or if you want to come to visit New York, shoot me an email. And that's it.
Hi, Alex. The audience has one question.
Okay.
Why do you use CDN like Akamai?
Yeah. Why don't we use a CDN? That's a good question. I don't know if using Akamai or something like that would fit in our system. I don't think we really need it. We're not delivering a lot of content to users. We're uploading the content from users and turning around and sending that to a store in a special format. And each package is different, and each store is different. So, yeah, I don't think it would fit for our needs.
Thank you.
Okay.
時間ですので、これでクエスチョンは打ち止めでよろしいですか? Thank you, Alex.
Okay. ありがとう。